Hello everybody, welcome back. Welcome to Creation Myths for part 3 of Busting, I want to get the full name, Dismantled, a scientific deconstruction of the theory of evolution, which I learned just today as I was doing some background research on this, was written by our mutual friend, Christopher Roop, if you go to IMDb. So,
you are kidding me.
100%, you can look it up. So that explains a lot of what's going on here, I think.
That explains a lot. If this was written by Group, that also explains why he's probably not talking about fossils very much.
Before we go any further, let me introduce my guest. Above me is Dapper Dino, and below me is Erica Gutsick Gibbon. Would you like to take a moment, Dapper and Erica? Take a moment, just tell us who you are.
I'm Dapper Dinosaur. Okay, I'm Dapper Dinosaur. I have a channel by the name Dapper Dinosaur. It does a lot of creation debunking, but there's some other stuff on there too. There's some weird archaeology, conspiracy theories. There's like spirit science nonsense. There's some medical misinformation debunking. So it's a little bit of a grab bag, but the theme is people say stupid things, and I point out why it's stupid and why they're wrong.
You love to see it. America, I'm Gutsick Gibbon. I do very similar things on my channel. I pepper in some science stuff that is, purely for the enjoyment of how cool and awesome paleoanthropology or primatology or general paleo really is. But for the most part, I too am caught by the forever alluring gaze of pseudoscience bust.
Yeah. And for those of you who wandered in to part 3 of this series and don't know who I am, hi, I'm Dr. Dan. I'm an evolutionary biologist. My channel is this, because this part is on my channel. It's Creation Myths. I take a look at very specific claims from creation science, and I show why they're terrible. So, without further ado, today we are here in part 3 of our series on this dismantled documentary, and in part 3 we are going to talk about the idea that Mitochondrial Eve and Y-chromosome Adam lived in the recent past. And by recent, we mean within the last 6,000 years. So we, in our first 2 parts here, we made it, as you can see, 8 minutes and 41 seconds into this half-hour segment of Dismantled. We are going, in this part, going to cover approximately another 9 minutes. They say a lot of stuff here, like multiple times. Like there's a lot of errors that they're just going to repeat over and over again. So just be ready for it, everybody. So without further ado, we're going to get going. We're just going to get right into it. And we're actually, you know what? No, we're not going to get right into it, because before we do this, I actually want to see Dapper and Erica. Neither of you are genetics people, so I want to let's make some testable predictions. Let's do the gold standard of science. What are we going to hear today? Erica, what are we going to hear today? What do you expect out of this segment?
Well, if I had to guess, considering that this is time's most recent common ancestor, this is going to be a veiled attack and veiled criticism of Josh Swabados's work. And essentially what it's going to propose is that not only did Adam and Eve live contemporaneously with one another, like Y-chromosomal Adam and mitochondrial Eve, but they did so approximately 6,000 years ago, and that this is backed by the empirical work of legitimate scientists.
There you go. And Dapper, what would you like to add?
So I think we're going to get references to a certain roughly 4-page Ann Gibbons article. Like, I'm not even sure if it's really a paper, because like it doesn't have like the formatting of a paper. It doesn't.
I think it's a research note. I think is what you're talking about. Yeah.
There you go. Yeah, her research note, which by the way I quite enjoyed reading, and it was really cool. And the creationists get it badly wrong. I also think we're going to get complaints about why it is that real scientists don't just assume the pedigree mutation rates carry on through time forever and ever. I think we're going to see some complaints about that.
I think you're right.
And also we're going to get like, well, these are the measured mutation rates, which is true, but then they're going to just incorrectly state, and evolutionists just assume slower mutation rates, even though, no, that's not assumed, that's measured.
So let's get right into it. Here we go.
If humans did not evolve from ape-like creatures, then where did we come from? The Genesis account of creation states that God made Adam and Eve, not as mythical beings, but as the literal historical ancestors of all living people.
Okay,
They were
hold on
the
a second.
first.
So, this is not a scientific point. This is a literary point. Genesis reads like any other creation myth. To say that they're presented as literal and not as mythical is to both must understand the genre you're in as well as what myths are. So, it's not a big scientific point. I'm just going to say, like, creationists, in many cases, you're even bad at reading your favorite book. Get better at it.
Well, and the thing is that it's like they're so keen. Christians are so weird about expertise, right? It's always trust the experts when they're in their corner, and it's never trust them if they're not. And this goes for biblical scholars just as much as it goes for anything, strictly scientific, which is why they're very happy to take the word of biblical scholars when it's talking about, where Exodus occurred on approximately what time. But boy, oh boy, when it comes to talking about how Genesis is actually exalted prose or a cosmic temple analogy or literally anything but meant to be a literal interpretation, they get their undies in a massive twist. And this is indeed the case. The vast majority of biblical scholars, in fact, I struggle to think of one that disagrees with this, takes the stance that this is probably allegory, or potentially allegory that is also acting as a polemic against the Babylonians, of whom they were just in captivity by.
2 human beings created, with all humans descending from this first couple. From a purely genetic standpoint, is it scientifically feasible that all humans descended from a single mother and a single father? Many insist this is absurd, and
So this is the first point where they're like, coalescence? Who would have thought? And the answer is all evolutionary biologists, because that's how it works. Like,
yeah, it's a mathematical certainty.
That
you will eventually coalesce for any given part of the genome.
If you
I do love this. I do love this recurring theme that young Earth creationists have kind of been beating to death for the past 80 years, which is, look at this thing that creationists noticed, and then it's always secular science or conventional science that's carrying it out every single time. And they really do just hope that no one notices. They just hope no one looks into it.
Well, it's because their target audience isn't going to look into it.
This is true.
Yeah.
Because one of the things is they pretend that their target audience is people like us, who are either currently in academia or who are interested and reasonably well-informed lay people who can check up on this stuff. We are not their target audience. Their target audience is some guy in church who has a job that has nothing to do with biology, which is obviously there's nothing wrong with that. Most jobs have nothing to do with it, and they're great jobs. But anyway, who says, oh, well, this sounds smart. This sounds intelligent. These guys have a PhD. So yeah, okay, that makes sense. I guess evolution is stupid then.
Yep.
Well, and it's all about Ken Ham using young Earth creationism to fight his weird proxy war with the culture war, right?
Yeah.
Like, it's so strange.
Yeah, he's really going down that, like, just all in on culture war stuff and using evolution as the in and just applying that to everything. So yeah, I think this is exactly kind of leading there of just like stupid scientists.
yet the genetic evidence for a literal Adam and Eve is inside each one of us.
It's not a literal Adam and Eve because it's only 2 teensy parts of our DNA. The rest of it doesn't converge to the same point.
Are you saying that not every chromosome is going to converge those same 2 common ancestors as the Y and the mitochondrial?
I am. Would you believe it?
Weird.
You should believe it because
believe that, yes.
the inheritance patterns are different, so they should have different convergence patterns.
I agree.
How strange.
It's weird. All right.
It's found in our DNA.
In 1987, a milestone paper was published in the journal Nature by leading evolutionary geneticists who announced the results of a mitochondrial DNA analysis. Geneticists from the University of California found that all humans are descended from one woman thought to have lived in Africa 100,000 to 200,000 years ago. Their results sent shockwaves throughout the scientific community and called for a major rewrite of the evolutionary view of human origins to accommodate the new data.
Erica, you appear to be in pain. Tell us why.
God, because such a smart group of people. We sure are bad at naming things. We could have called it anything besides mitochondrial Eve, but we just had to call it that anyways, because it is apt. But people saw that and went absolutely crazy. I'm also annoyed because they took the highlighted section, probably about 200,000 years, and they went probably 100 to 200,000 years, because that's what they always do. They take the absolute earliest possible age, and they make that the probable one, despite the fact that these are not all weighed equally.
Right. It's a distribution, and we see this, like, for example, with our friend Dr. Nathaniel Jeanson, Harvard PhD, who does this where he takes this range and he calculates a range of dates, and then he plucks the most aggressive parameters of, like, generation time and mutation rate, and he takes the most aggressive numbers of anything to get at one extreme range of his distribution to get the 6,000 years. And it's like, well, it's not how you do it.
We're going to get there. I know we're going to get there. This is going to be, this is going to be dicey. The Jeanson stuff, especially with that Santos et al. And Parsons and Howell and all that nonsense, I'm sure we're going to touch on that.
The other side of this little bit that we just heard was that, major rewrite of our understanding of human evolution, as though no one had thought of phylogenetic convergence before then. It's like, no. That's everyone, like, that's how it works. Erica, I had watched this part and took some notes ahead of time. There's a claim coming up that's going to make you, in particular, lose your mind. I am 100% sure of it. And
wait, that's not reassuring.
It's very soon.
I feel like it might not happen in this video, but I feel like in another, because these are like segments of this documentary, right?
Right.
We're doing like the genetic segment on human origins. But I feel like in one of the other segments, they're going to bring up that paper that everyone in the news reported as saying every species on Earth is basically like 200,000 years old.
They probably are going to do that.
What it actually meant was like, hey, every species on Earth has, if you average them together, there's like a 200,000 year time to like mitochondrial coalescence in each species. And
not even whole mitochondria for that paper. It was just a little segment of the mitochondria.
Oh goodness.
Yeah.
Another issue, that Dapper just presented, it does pop up all the time, is that idea where it's like they take a thing that evolution would have, or even in some cases just did predict way ahead of time, 50, 60 years ago in some cases. And they point to that and they say, oh my God, they're rewriting the whole story. Look at this. This is incredible. When really what's happened is a prediction was made and we did not have the tools to test it at that time. When the tools come along, we finally test it and we say, hey, this is really big news for evolutionary theory. That does not mean that the whole thing gets crumpled up and thrown in the trash and we start again. But even if it did mean that, as usual, science is meant to change when new data comes to light. That accommodation is what makes it so great.
Yeah. All right. Because Erica's going to love the next minute or so. I promise. Ready for it?
Yeah.
The revision gave rise to the now widely accepted out-of-Africa theory.
Oh my God.
Proponents of the theory couldn't...
1987, out of Africa, 1987, right?
Oh my God.
We broke Erica. 10 minutes. It took 10 minutes to break Erica's brain. It took 10 minutes of this documentary, and it has broken
Darwin
Erica.
propose out of Africa?
Yes, Darwin was one of the first people to suggest that it was probably within the heart of Africa that humans did indeed emerge. But, I mean, oh my God, Raymond Dart.
They just told me it was 1987.
Yeah, except Raymond Dart lived in the 40s. Like, what are we talking about here? The tall child was found in South Africa, and so...
Okay.
They're going to keep going on the out of Africa thing.
Don't worry. Later, not the next segment. The next. So, by the way, just context for everybody. The next part in this series that we're going to do is created heterozygosity. That's going to be with Dapper, and then after that, we're going to talk about out of Africa. That's going to be back here. We're going to do a whole thing on it because the writers here really like out of Middle East. So we're going to have a field day with that.
Just to apologize really quick, I just double checked because I actually mixed up my hominids, which is probably the worst possible thing someone like me can do. It was actually the 20s that Raymond Dart discovered the tall child.
How
not the 40s. My mistake.
Awful. Forced into early retirement.
Erica, you're done.
All right, here we go.
Gutsick Gibbon annihilated.
couldn't help but notice its uncanny resemblance to the biblical Eve. In acknowledgement of this, they gave the genetic mother of us all the name Mitochondrial Eve.
We already commented on, marketing.
Argument from etymology
Yeah.
doesn't mean...
Also, may I just make the point? This is because it was Western scientists who were primarily working on this, which is why they called it Mitochondrial Eve instead of one of the hundreds of thousands of other mothers of us all that exist in collective human mythos. Yeah. So, I mean, if we really want to poke holes in the minutia here, it is not that uncommon to have a universal mother of us all. And saying that this is paying homage, it says more about, kind of the Western influence here than anything else.
Yeah, this is evidence for Eve in the same way that the planet Jupiter is evidence for the god Jupiter.
According to the evolutionary perspective, mitochondrial Eve was an unnamed woman who evolved out of Africa from a Homo erectus population of apes.
Yeah, she probably had a name. We just don't know it.
Was it Homo erectus?
No.
No, it wasn't Homo erectus.
Did we think it was Homo erectus in 1987?
In 1987, even then, no, we wouldn't have thought that it was Homo erectus. We would have proposed that it was Homo heidelbergensis or rhodesiensis or something along those lines. And some of these names have sort of fallen by the wayside, but, and most of this is complicated because the nomenclature has to stick with the holotype, right? So, Trinal 1, or Trinal 2, rather, is going to be your Homo erectus. But, golly, this was made this year. This was made
2020. This is 2020.
2020. Okay, my mistake.
So they should know about Homo heidelbergensis when this was made. They should know about that.
Not only should they know about Homo heidelbergensis, but they should also appreciate the pulses of out of Africa. I mean, the nature of out of Africa is not as simple as a group of people left a single time. Yeah. 100 to 200,000 years ago. It's in fact, the final push was something like 50 to 70,000 years ago, maybe as recent as 30. Right. So to propose that this is, as straightforward, and I get that they're trying to do a short documentary or whatever, but man, their root is showing. Their Christopher root is very blatant in this part.
Never show your group.
Not long after the first mitochondrial DNA studies revealed a single mother of us all, evolutionary geneticists found similar results when analyzing sequences on the male Y-chromosome.
Okay, again, this is a requirement for evolution. If you did this kind of analysis and you didn't converge in a most recent common ancestor, then evolution is false. They're presenting this as whoa, look at this big surprising finding. Who would have ever thought in a million years? No, if this didn't happen, if you didn't get most recent common ancestors, then evolution is false. Period.
And this speaks to yet another thing that they're classically known for, which is to take the well-known creationism stances and just pretend like they never happened, right? Let's pretend that creationists hadn't been harping up until this point for decades and decades and decades and decades and decades, that you weren't going to find coalescence that goes back, to a universal common ancestor. Now they say, wait a second, we can accommodate this data by fixing it into our preconceived notion of coalescence, but only within the human, kind or whatever. Yeah. But they fought tooth and nail against coalescence all through the 80s and the 90s.
Yeah. Well, I mean, they do it with all sorts of things. I mean, look at transitional fossils. There are no transitional fossils. Then suddenly it's well, okay. Within family, there's lots of transitional fossils.
It doesn't matter.
Because, we need the transitions within families, at least for Cenozoic animals. So, AIG accepts, the giraffid fossil record just fine, even though it's full of transitional fossils. Even though they were also arguing you couldn't evolve a giraffe because of its complicated neck.
They propose, they are okay with the possibility that Noah took Indo-Hyas on the Ark, and that cetaceans evolved after that.
That wasn't. I don't think that's not AIG as a whole, is it? Because
no, it's just their Ark encounter exhibit. It's just their Ark, and they have a plaque that
on the
says,
kinds.
On the kind. It's on the kinds, but it's also they have little Indo-Hyoids sitting in a little kennel, and they have a plaque out in front of it that says, we're not sure whether or not Noah took Indo-Hyas on the ark, or whether or not whales were already in existence, their own kind, and swimming around during the flood. But it is possible that it could be either way.
Interesting.
Which is their non-committal way of saying, shit, the support for cetacean evolution is really, really good. Well, so let's just leave room.
That goes back to Todd Wood, who, when doing baraminology, couldn't successfully disconfirm the single kind for all cetaceans, including like protocetids and like pachycetids. He couldn't exclude that possibility.
In 1997, a team of researchers from Stanford University reported to the American Society of Human Genetics that all men inherited their Y chromosome from a single male ancestor. The sequencing of thousands of Y chromosomes from diverse people groups living around the world has revealed an overall lack of Y chromosome diversity.
Oh, hey, real quick. So they just showed that unrooted Y chromosome haplogroup tree.
They did.
And the thing that I love about it is that if you assume what the creationists assume, which is that when you have that little like bloom on the left, that the root of that tree is somewhere there, it raises the interesting question of why haplotypes A and B have so many mutations. What happened to those groups? Were they like irradiated or something? How'd they get that many mutations? Because you can look at the distance.
There it is, yeah.
And A and B are significantly more distant from each other than that other group is all in there, which is why it's usually, when you need to root this, you put it where that arrow is between A and B, because that's where it makes sense.
The answer is on the tree. They're saying, hey, here's where we think it is, right there.
With good reason. Because look at the branch lengths.
Yeah.
So for people who are unfamiliar with how this works, branch lengths are supposed to be proportional to the amount of genetic distance between the groups.
It's right there.
Yeah, it's on the scale. Right. And then, but the creationists are just like, nah, I see a little diagonal bit in the middle of this like flower-like.
Like right over here.
Let's just put it there for some
reason. They put it like in here or in here somewhere. Yeah.
Yeah, because that. Oh wait, no, that doesn't make a lick of sense.
Yeah, no, that doesn't make any sense.
Of Y chromosomes from diverse people groups living around the world has revealed an overall lack of Y chromosome diversity. All men share the same Y chromosome, plus a small number of mutations consistent with a single male ancestor of the human race.
Single ancestor for the Y chromosome, not the rest of the genome.
Also, that was a clear implication that evolutionists, quote unquote, should think that the Y chromosome atom wasn't a Homo sapiens. No one thinks that should be the case, because by saying a single human ancestor, they're implying that we think maybe it was
that would be a non-human.
No.
Yeah.
No one thinks that Y chromosome atom shouldn't have been Homo sapiens. That's ridiculous.
Once again, evolutionary geneticists couldn't help but give the father of us all a biblical name, Y chromosome Adam.
Didn't have to do that.
And Gibbon's drink.
Mitochondrial Eve. Evolutionists interpret Y chromosome Adam to be an evolved ape man from Africa.
Evolved ape man. I just want to comment on that. They can't use like real science words. They just say evolved ape man, which like
isn't that all wouldn't that just be humans as a group?
We're all evolved.
Genus,
well,
Homo,
people.
Everything evolved. We're all apes. Well, you're all apes.
Yeah, tell me you see this too. Like saying evolved ape man again, like Dapper said, this is an attempt to characterize the evolutionists, quote unquote, as proposing that Y chromosomal Adam was not Homo sapiens. This guy lived 100 to 200,000 years ago, according to their own chart in the background, which is the human range again. Mm-hmm. And it's in Africa, but I mean, I'm sure we're going to get to that. I'm sure we're going to get to.
We're going to keep going. We're going to keep going because another one of our friends is going to make an appearance shortly. So just.
Oh, good.
Time around 100,000 to 200,000 years ago.
The evolutionary community acknowledges that there is a literal Y chromosome Adam, and there is a literal mitochondrial Eve.
Okay, so first, did you recognize the voice before the face popped up?
It was Sanford. The
We're back to Sanford. Second, the evolutionary community acknowledges, because that's a requirement of evolution. If there wasn't a most recent common ancestor, evolution wouldn't work.
It would suggest independent origin.
Gotcha.
It would suggest.
Did you know that the Christian community acknowledges that the Roman Empire existed?
Whoa.
Can you believe
huge, if true.
Yeah, this is crazy.
Yeah.
It's the same. It's the same thing.
I
all know this.
I love the attitude of like, they acknowledge a most recent common ancestor. Got him.
They confess. They admit.
Let's just ignore the idea that universal common ancestry. It's in the name. We think everything has a common ancestor.
Yeah.
Dude, the framing of this is just so dishonest. Yeah. It's actually just so dishonest.
The whole thing so far has just been, look, it converges just like the Bible says. Evolutionists didn't think that, when that's actually exactly what the theory of evolution requires. Yeah, it's
again,
totally
this is just them. This is just them taking what conventional science has accepted for decades and trying to accommodate it. That's all any of this is, and then pretending like they found it. It's that cartoon where it's like, look, I made this, and he gives it to another guy, and he goes, I made this. It's just like,
and then he walks away with it.
Yeah.
All right, let's see what our friend says.
They say it's clear that all of the Y chromosomes on this planet trace back to a single individual who didn't live so long ago.
Well, human
Y chromosomes only passed on through the male, right?
True, fair enough. Human Y chromosomes, single individual, yes.
Yeah, there are other XY species that have independent origin for XY sex determination.
The part of that I love is didn't live so long ago. I'm going to need a citation.
So long for you.
I'm going to need a citation on that one, because I think when we say it wasn't that long ago, we mean something different than you do, Dr. Sanford. I think we mean different things.
Yeah, I do a lot of paleo content. For me, 200,000 years ago is like
it's not yesterday.
That long ago.
It's not that long ago.
But for a young Earth creationist who thinks that the world is like 1,000 times younger than that, well, okay, not 1,000. That was 100 times younger. Forgive me, creationists. You have to give me a free order of magnitude every once in a while, since we give them to you.
Give them to you all the time. We're just handing them out.
Right.
It's candy.
Yeah, about 100 times older than the universe is supposed to be. Unless, of course, Adam was polyploid.
We'll get there when we do heterozygosity. Okay. We'll get there.
Okay.
Well, the mitochondrial chromosome is only transmitted through the female. And that chromosome also, all the geneticists agree,
not a chromosome.
All people on the planet get their mitochondria from a woman who lived not so long ago, and it's uncontested.
And it's uncontested, as though this is a giant concession that evolutionists are making. And they admit it. What are we doing here?
The confession.
Accept common ancestry. Oh my goodness.
This would be akin to young Earth creationists who think that all felids are within a single kind, going, look, don't you see? Even the evolutionists have admitted, confessed, that all felids are related into a single group called Felidae, and it's like, yes, that is the point.
As Dapper said before, universal common ancestry. It's in the name. It's in the name.
And it turns out initially the evolutionists said, yeah, but it looks from our estimates of how long ago those individuals lived.
Here we go.
That they didn't live in the same time span. Now, actually, if they've reworked their numbers, they're always reassessing their time scales.
They're
Adam and Eve,
for new data.
The mitochondrial Eve and the Y chromosome Adam, they are in the same time span.
So I actually just want to point out that the estimates right now, there's wide ranges because you sample different data sets. You've been a lot of studies on this over the years. The range is now, it's 1 to 200,000 years for the mitochondrial DNA. It's 2 to 300,000 years for the Y chromosome. Again, these are wide ranges. It's a distribution where the probability that they're somewhere in the middle of the range is much higher than, we have much more confidence for the middle of that range than the ends of that range. It is theoretically possible that they overlap a little bit, but in general, the ranges as of right now, it's just, you can call them overlapping, but like it's just barely.
The same data and analysis that you are using in order to get those ranges in which they overlap also secure them at 200,000 years.
Right. If they overlap, it's approximately.
You can't get them contemporaneous if you don't give it up that it's indeed far in the past.
This is a trick that creationists love to use. They take a finding and they accept part of it, but not all of it. So they'll be like, okay, they overlap. Okay, the techniques that we use to find that the ranges may overlap gives us a range well outside the young Earth time. Oh, well, we don't care about that part of the analysis. We just care about the overlapping. It's the same effing technique. Either you accept the findings or you don't. You can't pick and choose which, like, I did an analysis and I found A, B, and C. You can't just be like, well, I accept A, but B and C, It's like, well, it's all the same numbers. You know, you do the analysis and you get the numbers and they are what they are. You can't just, like, reject some of them because you don't like them. I mean, you can, and that's what creationists do, but, like, you can't do that if you're doing science.
Lest we forget, like, theoretically, if you really wanted to, you know, they could come in and they could say, we agree with the contemporaneity part, and then they could delve into how they parse it out, right? How they say, we agree with the contemporaneity, but not with the time scale. And the way that you would do that, if you truly cared about the science, is you would go into the methodology and you would be able to parse it out in such a way, which you can't, because as Dan said, these methods are deeply intertwined and interdependent, but you would at least make an effort to say, here's the reason why we only accept part of that. Instead, what they do is they obfuscate and they say, look, see, they're contemporaneous. And it's like, yes, if you take the most insane section, the most insane distance for mitochondrial Eve and most insane recency for Y-chromosomal Adam, you might get them to be contemporaneous. We don't know if they were in the same spot. Contemporaneous just means they were in the same time and roughly the same place, in this case being Central Africa, which is quite large as a location. But yeah, you got to provide a reason as to why you're not accepting the age with that as well.
Counterpoint. No, I don't.
You're stupid.
Like, no, I don't. I'm
You're
just going to say
stupid and mean. I don't have to do anything. You have to say, tell me what to do again. See what happens.
If I'm a creation, no, I don't. I'm just going to say it. I'm just going to say it. Yep. I don't have to provide a reason.
You really can just say things.
There are two fundamental differences between the Adam and Eve of the Bible and the evolutionary interpretation of mitochondrial Eve and Y-chromosome Adam. The first difference has to do with time, and the second has to do with population size.
So those are
two big differences.
Just a programming note for everyone. So what we're going to do here is we're going to cover this time part in this segment, and then that population size segment is going to run into the next. That's what we're going to start with in the next segment in this series when we talk about created heterozygosity, because the population size just runs directly into the how do you get enough genetic diversity question. So we're going to cover. We're at 13 minutes here, so we're going to cover about the next 4.5 minutes on this this time question, and then we'll call it good, and then in the next segment we'll pick up with that population size stuff, which leads to diversity,
which will be on the Dapper Dino.
That will be with Dapper Dino.
The Genesis account indicates Adam and Eve lived recently, just thousands of years ago, and that they were the only two people alive at the time of their creation. The evolutionary model claims they lived around 100,000 to 200,000 years ago and belonged to a hominin population of 10,000 individuals. But
tens of thousands, not literally 10,000. 5 digits.
Also, did you notice that she said that they existed 100 to 200,000 years ago? No. One existed 100 to 200,000 years ago.
Yeah.
The other one 200 to 3,000.
Yeah, they're not using the right range for Y chromosome.
Not the same range.
Yeah.
Guys, again, a hominin subpopulation. We're talking about humans. We're talking about archaic Homo sapiens again. They're saying hominin to try to make it seem like these two things are disparate, because the punchline here is they're going to say everyone agrees that they're human. Hoo-hoo, looks like that's a point in negative of the evolutionists.
Yeah.
Excuse me? Why are we? Oh my God. Okay, let's just keep going.
Yeah, they're just to make sure we're all on the same page. The consensus range, and Erica, correct me if I'm wrong on this, but the consensus range for the earliest, what we would consider anatomically modern humans, Homo sapiens, you're looking at 200 to 300,000 years, give or take.
It's pretty firmly around 300,000.
Yeah, okay.
If we're looking at a combination of the paleontologic record and molecular clock stuff, it's pretty firmly around 300.
Okay. That makes sense. Yeah.
But I think usually people say 250 to 300,000, but it would make sense, right? Because if Y chromosome Adam is 2 to 300,000
then
years
that's
ago,
it's what I've read is that Y chromosome Adam is thought to be approximately contemporaneous with the origin of Homo sapiens.
Right.
Which, when you think about it, that makes sense. That checks out.
Well, and I'm sure we'll talk about this later, but part of how we know that is these nesting patterns within, at least with mitochondrial DNA, that nest very well within Central Africa. And that is not the Middle East.
Yeah, we're gonna get there. That's part 5, I think. We're gonna have so much fun with that. I can't wait. All right.
But as you will see, it's not the genetic data that conflicts with the biblical account of Adam and Eve. The conflict comes from inferences about time and population size.
Just gonna pause right here. Inferences. This is what I think both of you said at the beginning, where they're going to drop a lot of. We've looked at the empirical rates. It turns out the way that like biologists who do this for a living, turns out we know what we're doing, and those rates that we calculate are also empirical. We can measure them against real populations. So just be aware this is a very common thing. And they're like, we use the real thing. Those stupid evolutionists, they're making all these silly assumptions. Like, no. We can actually directly test those hypotheses, and yeah, they're gonna do a lot of that here.
Dan, that sounds like Satan has control of you right now. I'm pretty sure that's what's happening.
I have heard that there is a school of thought among some of the young Earth community that the people who are strong proponents of evolutionary theory, like the people who teach it for a living, are actually possessed by demons. Let me put a little more specific on that one. Apparently, I've had guests on my channel who then subsequently said that people, not naming me, but people who teach evolution, are possessed by demons. So yeah, so there's a fun. I'm not gonna out the person, but there's a fun guessing game for you.
What a sad state of affairs, to be honest. Because if memory serves, Dan, you've had very few people who have come on the channel and like disliked their interaction with you. It's always been cordial. It's always been polite.
Yeah.
And what that effectively means is they were like, yeah, I mean, Dan's pretty nice for a demon.
For a demon.
Evolutionary geneticists estimate that genetic Adam and Eve lived around 100,000 to 200,000 years ago, using a method known as the molecular clock.
Okay.
The technique relies on the assumption that mutations accumulate in certain regions of the genome at a constant rate over deep time.
That's imprecise. It's not wrong, but it's imprecise, and it gives the wrong impression. Because at this point, I have to just very briefly explain the difference between a mutation rate and a substitution rate. So mutation rate is the rate at which changes occur in DNA. Right, so you have an error as you're copying your DNA. You got the wrong base is inserted. That's a mutation. Happens all the time. Now, substitution rate refers to the rate at which those mutations become fixed in a lineage. Right, within a lineage of it could be species, could be subset, whatever it is. It becomes fixed in whatever group you're looking at. So everybody has that mutation. Right. Another way to look at that is the rate at which those mutations accumulate in the population. Now, the mutation rates can be really high. But the substitution rate is a lot slower because of things like genetic drift and natural selection, which cause you to lose genetic diversity over generations. So given that mutation occurs in generation 1, there's a certain probability, and you can calculate this, assuming there's no fitness cost or anything, right? Assume it's a neutral mutation in a non-constrained region, blah, 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 blah. Assume a mutation occurs in generation 1. There's a certain probability, and you can do math on this, that mutation exists in generation 2, in generation 5, in 10, in 100, and 1,000, right? What's the probability that mutation persists? And what we find when we look at this, and we can do math on this and survey actual populations where we know how long in the past they diverged, we do this for humans and lots of other things, we can see that the probability of a mutation persisting decreases over time. So it starts off really high, right? A mutation occurs, obviously it's present in that generation. Next generation, you might lose it, but there's a pretty good chance that mutation is still there. 3, 4, 5. Over time, the probability of that mutation decreases. And what happens is that the mutation rate, the rate at which mutations occur, over time converges on the long-term substitution rate, the rate at which they accumulate. When we do molecular clock analysis, what you have to do is know where on that curve you are for where's your most recent common ancestor. Right? That's what matters. So what you need to do is use a bunch of different sets of data and cross-check them against each other and plot that curve. And that allows you to determine what rate is most appropriate. And what we do when we find that is we actually know for humans what the rate is, right? What that long-term rate is. So then we can do things like the whole human-wide phylogeny and calculate the time to the most recent common ancestor for all of humanity. Right, so this is math we can do based on data that's calibrated against known events. These are not assumptions. These are not things that are just untested. We can actually test these numbers. The creationists present it as I don't know, But that's not true. We like, these are all testable things, and we've tested them, we've cross-checked them, and we have real data here.
It's actually indefensible to me that they're taking the eyeballing it method that they accuse paleontologists of in, paleoanthropology, which at least that makes a little bit more sense, because you're looking at two skulls, and like, obviously very precise metrics are taken to, look at how these bones have presumably changed their time, if you're looking at what is, potentially a lineage. But to propose that eyeballing is going on in genetics is insane to me. It is indefensible. You have to know nothing about how this works to think that.
This is going to get so much worse. Just watch. This gets so much worse.
Come on, Parsons. Come on, Santos et al.
I would actually propose that they do know better and they're just lying.
I think that's...
Every day I get closer to that as well, Dapper. Every day I also get closer to that.
At least Sanford and Jeanson know better.
Jeanson knows better. He said so. Jeanson said so in his blog post. In his 2015, in his blog post in Answers Research Journal, which is the AIG in-house blog that they pretend is peer-reviewed. Jeanson says, we don't know if this rate represents this or that. He says it right in there.
Evolutionary scientists have to further assume that humans evolved from a chimp-like ancestor roughly 6 million years ago in order to...
Nope. Don't have to assume that. You can do this math just based on human populations with known divergence times. You don't have to assume that.
Also, we're going back to the implication that the common ancestor of humans and chimpanzees was basically just a chimpanzee.
Yeah.
Which is just not
That's
true.
wrong. That's wrong.
As we talked about last time, which you can see on my channel, chimpanzees are the more derived group rather than human. And by chimpanzee, I mean genus Pan.
Yeah.
Is more derived than genus Homo.
Pan, genus Homo. It
would be more accurate to say chimpanzees evolved from a human-like ancestor.
That would be more accurate.
You still shouldn't say it, but it's more accurate.
It's more accurate.
It
is less wrong to say it that way. Yeah. Okay, continuing. Because, it gets so much worse, I'm telling you.
To calibrate the molecular clock.
That's not how we calibrate it.
Both claims are problematic and have been called into question by the genetics community. Distinguished evolutionary geneticists...
Here's the quote. Here, ready for it? You know they're going to do a quote mine here. And I looked this one up just a few minutes before we started.
David Reich of Harvard confesses in the publication Nature. The fact that the clock is so uncertain is very problematic for us.
So look down here in the lower right-hand corner, okay? So this is David Reich of Harvard. They compared 45,000-year-old human from Siberia, right, so preserved human remains, with genomes of modern humans and came up with a slower mutation rate. They also they calculated an intermediate rate, so a faster rate, by looking at differences between modern individuals.
Yeah.
So if you compare something from 45,000 years ago with modern things, you get a slower rate. But if you compare two things or more that are modern, you get a faster rate. Let me see if I can... They're this close to getting it. They're like this close, and they're like, I see, completely wrong. But they're this close. It's because the modern humans share a more recent common ancestor than the human that's alive right now and the thing from 45,000 years ago.
I feel like it's time for a "Is this your wallet?" meme.
I was just gonna say it's not my wallet. I was opening my mouth to say that it's not my wallet this entire time. I mean, again, I'm trying not to spoil the punchline because Dennis.
I promise we're gonna get there. Don't worry, we'll just let it run because this is a quote mine. We're gonna let him do the quote mine, but the thing is, we know why they're seeing these differences. It's because you have populations that share a common ancestor at different points in the past, and that leads to falling along different parts of that curve. That's what we're seeing here. This is exactly what you get from lots of studies. That's how this works.
Side note, tough to set. That is not equivalent to 6,000 years old. This is the thing they do with radiometric dating too, where they say, ha, you got 3.8 billion on one rock, and then on the rock immediately adjacent to it, you got 3.79 billion years. I guess radiometric dating doesn't work. But boy, it sure does seem like it's close to, 3.795 billion, doesn't it?
Right.
And not 6,000. They do the same thing here. Any kind of non-direct answer that isn't verbatim what the hypothesis is means the whole thing should be thrown out in favor of young Earth creationism, which is insane.
Why would we do that? Let's continue.
Publication in Nature. The fact that the clock is so uncertain is very problematic for us. It means that the dates we get out of genetics are really quite embarrassingly bad and uncertain.
Yeah.
Hold on a second.
Yeah.
Like having a 100,000-year range.
That's bad. We would really like it to be a 10,000-year range. That would be awesome. But you know what's not in the 100,000-year range? 6,000 years ago.
Right. Yes, it is an embarrassingly bad range, but it's still completely nowhere close to what the creationists need.
And bonus, if they're talking about stuff, it sounds like they're talking about stuff other than Y chromosome and mitochondria in here. And if they are, then it's actually worse, because the mitochondria and the Y chromosome have the two most recent common ancestors of any human most recent common ancestor. Other genome segments in the autosomes have more distant common ancestors because they have larger effective population sizes, because they're diploid and they're inherited through both parents. So they converge necessarily even further in the past. So we don't actually have context here to say, are they talking about mitochondria, Y chromosome, or something else? Yeah. But if it's the something else, it could be 500,000 years. It could be a million years, right? It could be further, right? If you do hemoglobin, for example, is like several million years in the past is where you get the coalescence. Like, you could put a big error bar around a million years ago, and it's never going to overlap with 6,000 years ago.
It's sort of like, say me and my friend are arguing about the distance between our places, and I'm like, I think it's about 2 miles. He says, well, I think it's about 3. And then some third party drops in and says, have you considered the possibility of, say, 20 yards? And it's like, no, I haven't considered that possibility.
Scientists are now using a more straightforward approach to determine mutation rates that do not require ape-to-man evolutionary assumptions.
Never needed that.
It involves directly measuring mutation rates in the present, comparing parents and offspring, known as the pedigree method.
There it is.
When comparing DNA sequences between parents and children,
doesn't work.
The measured mutation rates are typically 10 to 20 times higher than those inferred based on assumptions of ape-to-man evolution.
Oh, I have to relocate. Wait, I have to relocate us because I was covering up half of that figure. So I apologize, everyone, but we're going to switch sides real fast here. I love this figure. I love this figure so much because they are this effing close to getting it. They're this close. Yeah. When you compare families, you get a fast rate because you know what families have? A really effing most recent common ancestor. So, you know
why we call them that.
So how many of all those mutations that occur in a given generation, how many of them have been weeded out when you look at a family?
Very few.
So I really like the framing here because they're basically like, see, evolutionists have had to come around to pedigree rates. They're forgetting, like, okay, so Jensen did this in Replacing Darwin too, right? And Eva Grad covered it in his coverage. And everyone's done this to death and shown, what Jensen's real issue is here, because he basically says, look, Parsons 1998, this guy who basically looked at mutation rates between a couple of different groups, he got an artificially fast rate that's never been able to be replicated, which is the problem. Howell, who came slightly after that, also got a pretty fast rate, significantly less fast than Parsons, and it has been replicated. So everyone was wondering to themselves, well, it sure is strange that we've got pedigree rates that seem to be so much faster than evolutionary rates, quote unquote. So Santos et al. Comes along in 2008, and they do next generation sequencing, and they're like, boy, wouldn't you know it? It seems like they are fundamentally different because of what Dan was just saying, and you can actually calibrate that difference, right? That's substitution rate. You can figure this shit out. It's not hard. And we've been using the differentiation between those two ever since. Now, Jensen skips over that whole part. He will happily cite Santos et al. And Parsons, despite the fact that Parsons was not used by anyone. It wasn't used. His material wasn't used by Santos.
So there's another thing that I think we're currently missing out on, which is one of the things that they said just now was that assuming ape-to-man evolution, we have to use these lower phylogenetic replacement rates. But just previously, they cited a paper about preserved human remains, indicating a lower phylogenetic replacement rate. So
yeah, you're so right.
Pick it, guys. Either we have to assume apes, or we got it from this. And here's the hint: your citation was actually correct. That was a good thing to cite.
Yep.
Yes, when comparing ancient human DNA to modern human DNA, we get significantly lower rates of phylogenetic replacement. So,
if anybody
to man assumption needed.
If anybody really wants to get into the weeds on this, I always recommend a paper called Correcting for Purifying Selection, an Improved Human Mitochondrial Molecular Clock by Soares et al. 2009. I'll link this in the description of the video. It goes through a bunch of these phylogenetic calibration points for known human migrations, like island colonization events, where we know this island was colonized this many thousand years ago. This one, this many thousand. Like, we have very tightly constrained dates for these events, and we know what the sister populations are. So we can just, like, measure in modern humans from, for one example, North Africa and Canary Islands. We know to within a 1,000-year range when that happened, right? And we do this all around the world. You find, like, we know there's very specific known divergence times. Take individuals from the sister populations, you compare them, you can calculate a rate. And when you do that, wouldn't you know it, in that paper, they plot out that curve I described. They're like, this point, this point, this point, this point, and you can plot out the curve and see at what point in the past it converges at that phylogenetic rate. This is 100% directly measured empirical measurements of divergence in extant, which is living humans, which does not involve any assumptions of human-chimp common ancestry. It's just straight up.
When the molecular clock is calibrated using the empirically measured mutation rates, both mitochondria...
I'm just going to let it run for like a minute here. It's just wrong. Like, this is just wrong.
Just let them go. Just let them go.
Eve and Y-chromosome Adam lived just thousands of years ago. In discussing
When you do the math wrong, you get the wrong answer. Yes.
the age of mitochondrial Eve, evolutionary scientists in Trends in Genetics acknowledge this discrepancy. mtDNA datasets often exhibit anomalous patterns. One of these anomalies is the discrepancy between mtDNA mutation rates observed in evolutionary timescales, for example, in dating the divergence between two species and those measured within family pedigrees. If the high mutation rates seen in some human pedigrees were used to calculate the age of our most recent female common ancestor, she would have lived just 6,000 years ago, a date more consistent with biblical Eve than mitochondrial Eve.
Okay. So this is from the Ann Gibbons research note, which is like a 4-page little bit that Ann Gibbons wrote about this very problem, where she noted in the note itself that certain groups, I believe she specifically used Tristan da Cunha, which has been well within historical times settled by a very small number of settlers from, I think it's Portugal. And currently they're currently governed by Great Britain. Whatever, it doesn't matter.
Something like that, yeah.
But so she was pointing out that measured phylogenetic replacement rate in this population is different than the pedigree rate that you get. Therefore, you have to come up with some way to calibrate how you're going to measure things based on how long ago things were, and like divergence times become a little bit complicated. You have to use like a sloping curve, some kind of decay rate thing.
Yeah.
And that's the whole point of her research note, was to say, hey guys, we have to pay attention to the differences in observed and measured pedigree versus phylogenetic replacement rates in extant human populations with a known very historical divergence time. And then here's creationists been like, evolutionists just make up this whole slower mutation rate. And Gibbon said so. No, she didn't.
This is a classic example of creationists using a source to argue the opposite of what the source says.
Yep.
This is what's going on here. And another really interesting thing about this case that I didn't realize actually until Dapper just pointed it out, we're talking about age of exploration, like European age of discovery. Creationists want to take that one generation rate and project it back in just a flat line, right? This is the rate, and it just generation after generation, that's the number of mutations. Okay. We can go back within, not even like we talk about recorded human history. We can go back into like stuff that happened extraordinarily recently and document directly this decay rate.
even under those extreme circumstances, notice that they say if the high mutation rate seen in some human pedigrees
not all,
to calculate the age of our most recent female comment. I mean, Gibbons here is being pretty pithy. Like, she's being kind of like, short and summarizing this relatively quickly, and she's being kind of quippy too, and being like, haha, look, it'd be closer to, biblically than mitochondrial. And they were like, she said it!
Dan, I looked up when the current population interest in nuclear was established. 1817. 200 years ago.
Okay.
1817.
All right.
So it's not. Yeah. So it's not. Yeah. It's not. I did math wrong a few minutes ago. It's not 600 years. It's 200 years ago, and we could see the decay over. Like, we could see the weeding out of mutations in just those few generations. Yeah. To say, call it 10 generations.
This is like 1817. Like, who cares if you're a creationist? People are writing record. Like, this is newer than the King James version, guys.
We know that
it's
happened.
Half the age of the King James version.
Yeah, we know that
settlement
happened.
of Tristan da Cunha.
Okay, that's terrible.
But were you there, Dan?
There's a long-standing debate and argument in genetics.
Geneticists?
Wait, hang on.
The difference between
What?
Apparently, just anyone can be a geneticist if you just write a dumb book that involves genetics.
Just lie. Just lie.
Right.
That's what's being done here. Are you kidding me?
By this definition, can we call raw matter a geneticist?
Yes.
Technically.
Yeah, I mean, it doesn't mean anything, apparently.
No.
Well, again, just to reiterate, marine biologist.
Anyway.
Marine biologist.
Yeah, all right.
between what's called the phylogenetic mutation rate.
Right. Oh,
and
wait for it
the
here. Just wait for it.
Genealogical mutation rate.
What?
If you look at a family, you can count the differences between the people and you say, oh, they've had some mutations. And you can actually calculate a mutation rate over time in today's time, in known time. Right now, we know what the mutation rate is. But the evolutionary community doesn't like to use that rate because it's too fast.
Sir, I will not say the rude thing I would like to say because that would result in this video getting demonetized. So I'm not going to say the rude thing that I want to say in response to that. But no, I mean, this is just like they're liars. This is just he's just saying we're liars.
17. We've known, according to your sources, there, Carter, that 1817 is enough time to notice a measurable difference between the phylogenetic replacement rate and this pedigree rate that you would prefer to use. This isn't a matter of conjecture. This isn't a matter of like, oh, well, we had to date some shards of pottery to figure out when the island was settled. 1817.
We wrote that one down.
205 years ago.
What a giant baby. I mean, she's seriously sitting here with the rest of them talking about how, the evolutionary community, they don't like that rate. It's too fast. And so they cover it up. The evil Gothic castle Illuminati evolutionist community is shrouding the truth for us. And it is up to the true-hearted young Earth creationists to discover it. What a baby. What a gigantic cop-out.
I get two things here. One, I'm sure when we're back on Dapper's channel, we'll be back in our Gothic castle plotting the demise of young Earth creationism, so don't worry. I'm sure we'll be back in our lair next time. But the second thing is, let's give Carter credit. Let's say, Dr. Rob Carter, geneticist. Fine. All good. You're a liar. Because you should know better if you're a geneticist. You know that what you're saying is wrong. You know that you're lying. If you're a geneticist, you know you're wrong.
The producers are lying by calling him a geneticist.
Or
he is a geneticist and he's lying.
Look, we've covered Rob Carter
one or the
before.
other. Screw this guy. It's not cool.
They use what's called the phylogenetic mutation rate. That is, they look at the difference between humans and chimpanzees.
No, we don't. It's not how you do that.
Not the real rate, but the differences. And they say, oh, we've been separated for so many millions of years. Now, when I was an undergraduate, that difference was 3 million years. Now it's 6 million years, 6.5 million years. Some people are arguing for 13 million years.
Who's arguing for 13 million years?
Hey,
No, we're not that.
Hey, Erica, why did the dates change over time?
Well, what an excellent question. It could be because perhaps more data has come to light and more fossils have been found. And boy, isn't it interesting that once we get things like the molecular clock coming onto the scene and the molecular clock is calibrated, right? Boy, isn't it strange that it corroborates the fossil dates that we get to around 7 million years?
No, see, whenever you get a fossil date that doesn't match your expectation, you throw that date out, obviously.
Yeah, we throw it out. We throw it out.
Right in the trash.
Yeah. The actual answer, sorry, Arca, that's wrong. The actual answer is it's because there is a conspiracy among biologists, and we're all knowingly lying to suppress the truth of young Earth creationism. And
let's be specific. Satanic conspiracy.
It's a satanic conspiracy. Yeah, so they don't let you all the way in with a master's degree, but don't worry, they'll let you in, and you'll get there.
Eventually. Yes.
Yeah.
Mm-hmm.
What a victim complex.
The last part.
I shouldn't be saying this actually.
Oh, okay.
I'm going to say it because I don't have the PhD, but I just happen to know. The last part of your PhD defense is actually a summoning circle where they summon the demon to come inhabit you.
That's actually after the defense. So that's after you pass. The last part of your defense. The last part of your defense is you have to fight a snake. Google that if you don't know what I'm talking about. The last part is you have to fight a snake, and then after that they do the summoning thing.
Do you get to pick what kind of snake it is? Because I just picked
no. The department. Google it. The department keeps a number of snakes. The department keeps a number of snakes for this purpose.
What a giant baby, though. Can you imagine having this level of persecution complex? Can you imagine thinking that conventional science actually thinks about young Earth creationism this much? When I tell people that we do what we do, they're like, "Oh my God, they're still around?" Yes, they are. Usually, the next question is, "Why do you bother?"
Why
and
do you
my
bother?
answer is, I hate myself.
That's a good question.
It's a really good question.
All right, we're drifting, so let's
we gotta get back.
We're almost done. We only have not even a minute left here.
Yeah.
Because mathematically they're having a hard time dealing with this.
No, we're not having a hard time dealing with it, Rob. That's just lying. Thank you.
Take the differences between humans and chimpanzees in some gene, like mitochondria, Y-chromosome, or something like that.
Those aren't genes.
Those aren't genes. Geneticist Rob Carter, some gene like the Y-chromosome.
Geneticist Rob
Those
Carter.
aren't genes.
Look,
those aren't genes.
I'm not a geneticist, right? I'm not a genetics guy. We've established this. But I know the difference between a mitochondrial genome, a gene, and a chromosome.
Divided by the time that separates us, 6 million years, you get a very slow mutation rate.
Yes, you do.
But if you look at the people alive today, count up the number of differences between them, and divide by the time since their ancestor, maybe their great-great-grandfather or something like that, and you're going to get a mutation rate much faster.
Right.
Yes, he just explained it correctly, right? He just explained exactly how it works correctly. Because if you have a common ancestor in the distant past, mutations get weeded out over time. If you have a common ancestor very recently, the mutations that occur in each generation haven't had time to get weeded out. So you see a higher rate for a recent common ancestor, and you see a slower rate for a more distant common ancestor. That's exactly... He just got it right.
It's
and then
just
he just
not my wallet.
We're right back to, can you believe that the Christians admit that Herod Antipas was a real historical figure? Yeah, he's in the Bible. Of course they do. You can't say, can you believe that evolutionists believe the things that were predicted by evolution? Because of course they do, especially when they were then confirmed.
Well, come on now, Dapper. He's a geneticist. I think he knows what he's talking about. We've just had such a jaw drop moment in every single one of these so far. Last time it was the abstract. This time it's just Rob Carter, not dabbled in genetics as they tend to say for Jensen, where they'll be like, oh, Jensen has done a lot of genetics. It's Rob Carter, geneticist.
He explained it.
Press X to doubt.
He explained it correctly. He just explained it correctly. And then it's like, oh, well, gee, why is that the case? Because of how evolution works.
The basics of population genetics is the reason.
Yeah.
I get it.
When we use that rate,
that's all I had to
Adam
say.
and Eve fall into the biblical time frame. So when we
use the wrong math, we get the wrong answer.
Correct.
Yes.
That is how that works.
That is correct, Rob.
use today's science, measurable science, laboratory stuff we know is true, Adam and Eve are biblical.
Yeah, that sentence is wrong because when you actually use like correct coalescent techniques based on known divergence events, you get hundreds of thousands of years. That's just, yeah.
If you'll remember from our lovely graphic that was on the bottom left-hand side where it showed our little stick figures, the mutation rate of the pedigree was 10 to 20 times faster than the phylogenetic rate. 10 to 20. And you're telling me that zeroes in on 6,000 years? Might we see the math on that? Because something tells me that there's going to be a range there, and something tells me that range is perhaps not going to zero in on 6,000 years. It's just insane to me. It's so crazy to me that it's like, no wonder, you can tell that they're up a creek when they stop showing graphics. They just stand there and they talk over the music, and that's supposed to be enough.
So we're just about at the end here. I'm going to just play this for another few seconds because I think we're just on the cusp of getting to population size, which is where we're going to start part 4 in this series. So let me do that, and then I have a quick observation about how we handle these segments. So let me just play this, and then we'll wrap this up.
While the actual genetic data reveals a single mitochondrial Eve ancestor and a single Y-chromosome ancestor, evolutionists have insisted they must have lived in a larger population.
Yes. Okay. So that's where we're gonna cut off this segment, because they talk about population size, and specifically population size with genetic diversity, and that gets us into part 4 on created heterozygosity, which we will do on Dapper's channel. And remember, once each part is posted, I'll update the description down there, and you'll see all of them all laid out. So,
and I have a running playlist that I'm going to be adding to.
Before we get out here, I want to hear each of your final thoughts, but I just want to say that we've done 3 of these now, and by the end of each video, all 3 of us, our jaws we are aghast at how terrible this is. Each time we get to the end of the thing we're talking about, we're just like, I can't believe these people.
Yeah.
And every time. So,
this whole segment was basically, I can sum it up like this. It seems strange to us that people who promulgate biology, I'm not going to pretend biology, accept the predictions of the fundamental theory of biology, which is to say the theory of evolution. That's weird to us. We, who don't really do biology, who LARP at biology, would predict common ancestry for humans. Yes. Everyone predicts that Everyone predicts that.
It's really incredible to me that this is a documentary that got made, and that these organizations are still standing, right, with money just being pumped into them. Because what we effectively just saw, and what we've seen in the other 2 episodes, is that we see them take a concept and strawman it, or get it wrong, one or the other. Then they'll take a methodology that doesn't work, and they'll use that methodology to create an incorrect equation that they will then put incorrect math into. And then they will take that and get a range that just provides the possibility that they might be right. So the concepts are wrong, the equation is wrong, the data is used incorrectly, and the math plugged in to the equation that is wrong is also wrong. And even then, they can't get what they want. They can only get the possibility of what they want. Yeah. And that alone speaks volumes, because the way that science works isn't, hey, look, my thing is technically possible. The way that it works is, it's possible, and here's why we should take it seriously. Yeah. And we don't see that here. We don't see a lick of it, ever. They slap and go every single time and say, look, saying that it's possible with all of this, if you'll excuse me, batshit methodology, is completely appropriate. We're real scientists just like you. And then they wonder why they're seated at the kids' table.
Yeah. Yeah. I don't have a whole lot to add to that as we wrap this up. They take the wrong data. They start this whole thing with this idea of like, whoa, who'da thunk? Like everybody. We knew this.
Literally everyone.
Everybody. If it wasn't that, evolution would be wrong. And then they take, as Erica just explained, very artfully, a data set that's inappropriate, and they use a technique that's inappropriate, and they get a range that just barely overlaps what they're looking for, and they say, we're good. And it's like, no, you can't do that. That's not how any of this works. And also, it's a conspiracy theory, and that's why they're not taken seriously. No, my undergraduate students, I teach a 200-level course called Fundamentals of Evolution. It's just an overview of evolutionary biology. My undergraduate students in that course, by the end of that course, can understand why Jeanson's math for the recent most mitochondrial Eve is wrong. They understand the difference between a mutation rate and a substitution rate. And they know how they're relevant or not to phylogenetics and coalescence. They can explain why what we just saw is wrong. Undergraduates.
Yeah.
So, like, what are we doing here? It's not science.
There's no excuse. There's no excuse for this. These are adults. These are adult humans who have degrees. There is
who
no...
are allegedly geneticists themselves.
Yeah.
Who are geneticists, yes. I mean, why are we getting the basics wrong? And, you know, as we kind of all alluded to in the middle of the video, but it's harder and harder every time they put one of these things out to believe that this is an accident, to believe that this is ignorance when they know better.
I'm done. I've given up. This is lying. This is misrepresentation. This is fundamentally a dishonest enterprise. So that concludes part 3 in our exercise on Dismantled, a scientific deconstruction of the theory of evolution. As I look at over at OBS over here, we've been recording for about 90 minutes. I don't know how long this is going to end up when I edit it down a little bit, but probably not too much shorter.
About an hour 20.
So yeah, probably about an hour 20 or so. So I hope everybody enjoyed that. Now remember, part 1, we started the series. That was over on Erica's channel. Then part 2, we were over on Dapper Dino. Part 3, you're right here on Creation Myths. Part 4, we're going back to Dapper Dino. And then part 5, we're going to be back here. We're going to wrap it up with part 6 with Gutsick Gibbon. So all this stuff will be below as we release them, plus that paper that I'm 100% going to remember to put in the description.
60%.
That will 75%.
I'll beat you with 70.
All right, 70%. I'm probably going to remember to put that paper in the description. And I hope everybody has a great night. Remember to like this and subscribe. And if you're, for some reason, watching this and you're not already subscribed to Dapper Dino and Gutsick Gibbon, I'll put those in the description. 99% chance I remember to do that. And go subscribe to them as well. Thank you, everybody. Have a great night.